fractions is division? What fraction is division? Fractions is division. What fraction is division? Numerator divided by denominator. Numerator divided by denominator. Fractions is division. What fractions is division? Numerator divided by denominator. Numerator divided by denominator. Fractions is division. What fractions is division? And students don't have to know that in third grade, but knowing fractions and understanding fractions will lead to them understanding fractions is division. Okay? What fractions is division? Numerator divided by denominator. Numerator divided by denominator. Numerator, top number. Denominator, bottom number. Numerator, top number. Denominator, bottom number. Top number, how many equal parts? Bottom number, total number equal parts. Top number, how many equal parts? Bottom number, total number equal parts. Fraction is division. What fraction is division? Numerator divided by denominator. Numerator divided by denominator. Numerator, top number. Denominator, bottom number. Numerator, top number. Denominator, bottom number. Top number, how many equal parts? Bottom number, total number equal parts. Fraction is division. What fraction is division? Numerator divided by denominator. Numerator divided by denominator. Numerator, top number. Denominator, bottom number. Numerator, top number. Denominator, bottom number. Top number, how many equal parts? Bottom number, total number equal parts. Top number, how many equal parts? Bottom number, total number equal parts. For your child to understand numerator and denominator. If I have 3, 6, 3 is the numerator. How many equal parts? Numerator, how many equal parts? Top number, how many equal parts? Top number, how many equal parts? So how many equal parts? 6 is denominator. Total number equal parts. At 6, total number equal parts. Like the total number. So I'm looking at the denominator to tell me the total number equal parts. So if I have the total number of equal parts here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Alright, so total number is 6. And then it's telling me to shade what? 3. How many equal parts is that numerator telling me to shade? That's 3. So if I had a number line, it'll be what? 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and then of course 6, 6, which equal a whole. Because any number over itself equals a whole, okay? Okay, today I'm trying to teach about fractions. This is for a third grade student, understanding fractions as numbers. NC3 NF1 is what I'm focused on. My daughter is going to help me with just a few things I want to show you. All right, Destiny, I want you to fold that paper. Remember, that's a whole sheet. I want you to fold that paper into a half. Okay, we have 1 half. So, can you draw like where that line, where you folded that line, just so it could be clear? Okay. So, if I look, it's okay. You understand that this top part is 1 half, that bottom part is 1 half. So, that 1 half plus 1 half equals 1 whole, because 1 half plus 1 half equals 2 over 2. Which equals a whole. Any number over itself equals a whole. So if you have 2 over 2, or you have 3 over 3, if you have 4 over 4, if you have 100 over what? 100, all of this always equals 1 whole. Okay, no matter what you have, 5 over 5, it equals a whole. So that's one thing you definitely need to know. Especially in third grade and even later, especially later on. So I have 1 half and 1 half equals a whole. So now, Destiny, I want you to fold another sheet of paper. And I want you to fold it, not this time, not in a half. We'll fold a half. and then you're going to fold it again. So if you're at home watching, have your children fold the paper, go do this activity. So fold it again, yes, into fourths. So now it's folded into fourths, and I want you to do the same thing. I should have got you a better pen. This pen kind of is a little wiggly. But I need you to,
You want me to draw down?
Yes, yes. So right now, each box represents 1/4. So 1/4 plus 1/4 plus 1/4 plus 1/4 equals 4/4. And like we just talked about, 4/4 equals a whole. So what I'm gonna show you is that you can either, I'm about to teach more than just that 3NF1. I'm gonna teach a little bit about equivalent fractions too. So if you put that 1/2 paper behind that 2/4, yes. So if you look, this right here, this part equals 2/4, okay? If it was shaded, it would equal 2/4. So pretend like that part is shaded and put this halfway down, and that part equals what? 1/2. But they are the same, so that shows us that they're equivalent. They are equal to each other. 1/2 and 2/4 are equivalent because they are equal. It's the same amount of space is taken up. So now, Destiny, I want you to fold this sheet actually into 8. So fold it into a half, and then fold it again into fourths, and then fold it one more time, and it will become an 8. Okay, now open it. So now if you look at that whole sheet, it has become 8. That's 1 8, 1 8, 1 8, 1 8, 1 8, 1 8, 1 8, 1 8. That all equals, this whole thing equals 8/8, which equals 1 whole. But I want to know what's equivalent to 1/2 and what's equivalent to 2/4. So take those papers that you drew earlier and put it together with those other holes. Yes. So now you should be able to look at that paper and think about what 2/4, that 2/4 equal that 1/2. So what do you think would equal 1/2? Make sure the paper's aligned. What will equal 1/2? The 4/8, because that's halfway. 1, 2, 3, 4. 4/8 equals 1/2, and it's also equivalent to 2/4. So that was just a short lesson talking about unit fractions and how you need to actually see unit fractions. And this is something very important too when you're working with your children. What you have to interpret unit fraction with denominators of 2, 3, 4, 6, and 8. Okay? So if you look at that, the main denominators remember is the bottom number that we're going to be working with is that 2, 3, 4, 6, and 8. We just worked with 2, 4, and 8 because I just showed you 1/2, 2/4, and 4/8 are all equivalent to 1/2. They're all halves. So now I'm going to go a step further and start talking about number lines and actually being able to see it on NF2. Interpret fractions with denominators of 2, 3, 4, 6, and 8 using area and length models. Use the area model. Explain that the numerator of a fraction represents the number of equal parts of the unit fraction. Using a number line, explain that the numerator of a fraction represents the number of lengths of the unit fraction from 0. This one is in the unpacking documents from NCDPI. Brandy is making hair bows. Each hair bow takes 1/4 of a yard of ribbon to make. This is what she bought at the store. So that bar represents what she bought at the store. If she uses all the ribbon, how many bows can she make? It is very important for you to make sure you tell your child whenever they see a word problem, read it over and over to make sure it makes sense to them. It's just like comprehension with reading. They're comprehending the problem If she uses all the ribbon, how many bows can she make? So if she uses all the ribbon, how many bows can she make? I know that bar represents the ribbon, okay? So I already see something that tells me that is more than a whole, okay? So it's actually a whole, one whole, and 1/4 because it stops here. So the whole thing represents 1 and 1/4, but that's not what my question asked. The question said, if she uses all the ribbon, how many bows can she make? So if I go back up, it says each hair bow takes 1/4 of a yard of ribbon. So each hair bow. So if she uses all of them, how many hair bows? So if each hair bow takes 1/4, that means that's 1 hair bow, 2 hair bows, 3 hair bows, 4 hair bows, 5 hair bows. So how many can she make? She can make 5 hair bows based on what she bought at the store. Okay? So if your child still having questions like how can she make 5 hair bows, you have to read and make sure you're answering the question that's asked. If she uses all the ribbon, how many bows can she make? Brandy is making hair bows. Each hair bow takes 1/4 of a yard of ribbon to make. So if I think about my fourths, and I'll show you my handy duty number line whenever I'm doing equivalents. So if I have, let me go to the one that's 4. So that's right here. So if I know my halfway point is 2/4, then I know in between that 0 and that 2/4 is what? 1/4. In between that 2/4 and that 4/4 is what? 3/4. But then I had a whole nother piece of the ribbon. And that was what? 1/4. I had to start over because I already had my whole. And after I had my whole, then I had to continue and start over. And so that's how I knew that once I continue and start over, I have 1/4, a fourth, okay? So that means I have 5 pieces. I hope that makes sense. But if not, I'm always here to help. Just send me a message and I'll continue. And my last lesson is going to be about NC3 NF3, and that's represent equivalent fractions with area and length models. And I kind of showed you that in the beginning of the lesson whenever I showed you the white notebook paper. Well, it wasn't notebook paper, the white copy paper, and I had my daughter fold it into a half, and then I had her fold it into 4ths, and then I had her fold it into 8ths. But I'm going to go into some details using a number line, showing you the number line, and showing you how it represents equivalent fractions. So here it says represent equivalent fractions with area and length models by composing and decomposing fractions into equivalent fractions using related fractions, halves, 4ths, and 8ths, 3rds, and 6ths. So I'm gonna do halves, 4ths, and 8ths first, and then I'll do 3rds and 6ths. So here, expressing whole numbers as fractions and recognizing fractions that are equivalent to whole numbers. So I want to be able to recognize fractions that are equivalent to whole numbers. All right. So here, if you look here, it's some possible student responses. I love looking at unpacking and looking at student responses because it helps you see what they're thinking. And whenever you're talking to your child about fractions, you got to make sure they're thinking about fractions correctly, because sometimes their thought process on fractions is totally off. So that's very important. But these are some simple examples, but I'm about to show you some examples using what I have and things that I feel like have worked in the past. Okay, I'm about to draw some number lines, and they're not going to be perfect, but I think I can get my point across so students can understand what I'm doing. So here I'm making sure I'm making these number lines equal, because the key is whenever you're thinking about fractions, remember fractions are less than a whole. Like for the most part, unless you have a fraction that's over the whole, but like for example, if I have 4/4, 4/4 equals what? 1 whole. Now, I could have 4/4 and then have a whole and 1/4. I showed you that previously. So that means that's more than a whole, but the examples I'm doing all are less than a whole, okay? So here I have 0, so I have 0, I have 0, I have 0, okay? If that's 4/4, 2/2 equals what? 1 whole, of course. And then the other one, these are all related fractions. They're related, they're related. So that's that 4/4, that's that 2/2. And then 8/8 equals what? 1 whole, of course. So then they are related fractions. So I always teach students, once you figure out how they're all related. So I'm going to go here. Normally I would do my first one, my first number line actually with the halfway point. So my halfway point, I could fold it or whatever just to get in my mind. All this would be kind of my halfway point. So notice how they're all lined up. All right. So I have halfway of 0 and 2/2 is 1/2. Okay. So halfway of 0 and 4/4 is what? 2/4. That's halfway. Halfway of 0 and 8/8 is what? 4/8. That's my halfway. These are all equivalent fractions, okay? They're equivalent. So when I say equivalent, that means they are equal. They are equal. 2/4, 1/2, 4/8. They're all equal, okay? So if I look here and I say 0, okay, what's in between 0 and 2/4? There's a what? 1/4. So I have 0, 1/4, 2/4, and then what's in between 2/4 and 4/4? 3/4. So I have 0, 1/4, 2/4, 3/4, 4/4. So then I look here, 0, what's in between 1/2? Guess what? I have a half. I don't even have to do anything else. 1/2 and then 2/2. Let me keep going. Look here. 0, what's before that 4/8? What is less than 4/8? We have a what? We got a 1/8, yes.
2/8.
2/8.
3/8.
3/8. So what is more than 4/8?
5/8.
5/8. And I'm trying to make them all equal because they have to be equal. 6/8.
And 7/8.
And 7/8. And then I have my whole 8/8. So when I start asking questions like, and look, that's the thing too, like you have to make sure that students understand or your child understands. If I start asking questions like, is 1/4 less than 4/8? They need to know that 1/4 is definitely less than 4/8 because if you see how it's lined up, 4/8 is it's halfway to 8/8. 1/4 is less than the halfway point. But if I say 3/4 is 3/4 less than 1/2, the answer is no. 3/4 is not less than 1/2 because 3/4 is closer to 4/4, and 1/2 is halfway to 2/2, which is 1 whole. So lining it up and trying to make sure they understand what it means whenever you line it up, and how they're equivalent to each other and where they fall on the number line determines their placement with if they're more or less is very, very, very important for students to know at this age, especially in 3rd grade. So that's one thing they could do. Now, if I do, these are related fractions. 3/3 equals what? 1 whole. Trying to make it the same. 1 whole. 6/6 equals 1 whole. Related fractions, right? 0 and 0. So right now, I know I'm looking for where does 1/3 and 2/3 fall? In between this, right? So I'm going to say 1/3 is here, and I'm going to say 2/3 is here. Here, down here. I know that if I'm looking at 2/3, so 2 times 2 is what? 4. 3 times 2 is what? 6. So 4, 6. I know they supposed to be like the same spot, right? Because they equivalent to each other, right? Yes. So at least I know one spot, 5, 6. Then what becomes in between those? What have to come?
1 6.
1 6, and what else?
2 6.
2 6. 2 6 got to be equivalent to that 1/3, right? Because 1 times 2 is 2. 3 times 2 is 6. That's 2 6. So I know where that spot is. That's 1 6, 2 6, and 3 6. So I know my related fractions, okay? And even still, students need to understand that 3 6 equals the what? That's the halfway point, right? So that's the halfway point. So wherever it is, that would be considered more than halfway point, but there's no halfway point here. But you know that 2/3 is larger than what? 3 6. Because it's closer to 1 than 3 6. So that's why I tell students, just because you're in 3rd grade, don't let go of number lines. Number lines are very, very important. And even later on, 4th and 5th grade, you can still use number lines to understand fractions. I have other lessons on fractions, but I'm going to stop for today.